Hello everyone, welcome to another exciting math problem, this time involving the fractional parts of numbers. This question can be particularly challenging for many. Here is the problem. Suppose n is a positive integer. Prove that n times square root 7 times n squared 7 minus the floor of n squared 7 is at least 3 over 2. Before we uncover the solution, I encourage you to hit the pause button, grab your pen and paper and give your best shot. When you're ready, feel free to share answers in the comment. Then we explore the solution together. Let's get started. For any real number x, the term x minus floor of x refer to the fractional part of x, which lie between 0 and 1. Let x be n squared 7 for some positive integer n. In this case, x is not a positive integer. It's intriguing to observe that the conversion of square root of 7 are 2, 3, 5 over 2, 8 over 3, 37 over 14, 45 over 17, 82 over 31, and so on. We find that x times x minus the floor of x reach its maximum and minimum values when x equals to 3, 17, and x equals to 1, 2, 14, 31 respectively. Refer to the diagram to visualize this concept. After gaining some insight into the problem, let's proceed with a rigorous proof. Again, let x be n times square root 7. For all positive integers n, x is not a positive integer. However, x squared equals 7n squared is a positive integer. We'll use proof by contradiction to demonstrate the desired statement. Now assume x times x minus the floor of x is less than 3 over 2. Then x minus the floor of x is less than 3 over 2x. Since the floor of x is less than x, which can be written as the floor of x plus x minus the floor of x. With the previously mentioned inequality, x is less than the floor of x plus 3 over 2x. This implies that x minus 3 over 2x is less than the floor of x, which is less than x. Squaring each side, we obtain the following. Since both the square of floor of x and square of x are integers, from the previous calculation, it follows that x squared minus 2 is less than or equals to the square of floor of x less than or equals to x squared minus 1. This means that the square of floor of x can only be x squared minus 1 or x squared minus 2. We will show that neither is possible by considering number congruence modulo 8. Now, for any integer a squared is congruent to 1, 4, or 0 mod 8. Therefore, 7a squared is congruent to 7, 4, or 0 mod 8. Which implies that 7a squared minus 1 is congruent to 6, 3, or 7 mod 8. Given that x squared is of the form 7n squared, it's clear that the square of floor of x is not x squared minus 1. Continuing with 7a squared minus 2, which is congruent to 5, 2, or 6. We conclude from this equation that the square of floor of x is not x squared minus 2. This invalidates our assumption, confirming that x times x minus floor of x is at least 3 over 2. In fact, 3 over 2 is the infimum, as x times x minus the floor of x can get as close to 3 over 2 as possible. For instance, when n equals to 2 to 3, it is approximately 1.50000. That concludes today's lesson. I hope you found this video insightful and are looking forward to tackle more math challenges. Until next time, take care and bye-bye.